Below is a table containing the outcome of M&Ms in a bag, collected at random. The M&M company claims that the color distribution is as follows. So, the distribution is used to calculate the expected value right here, expected. And in calculating the expected, or E, is equal to the percent distribution, right, we'll put that, multiplied by total number of M&Ms. So, the observed is what we see in the bag, the number of blues that we actually see when we open the bag. Right? So, observed minus expected is those numbers there. And you see how there's a negative. Then you square it, so you get rid of the negative. We don't want the residual values. Instead, we want the squared residual. Divide by the expected. So, O minus E squared over E is equal to the chi-squared statistic. H null and the alternative hypothesis belong in your state section, as well as you have to establish your alpha level. So we are going to take the standard level of 0.05. The null hypothesis is that the distribution of colors in M&Ms. The alternative hypothesis, on the other hand, is that the distribution is incorrect. The plan, so you say what the three checks are: the random check, the sample size, and how independent it is. In this, it was stated in the original question that it was random. The individual bag of M&Ms was chosen at random. That tells you right there it's random, so we go ahead and check that. The large sample size, so the expected value is larger than 5. Because all of the expected values in our table are all greater than 5, we can say it's a large enough sample size. Thirdly, how independent? The event is independent clearly because pick step is to do. So if you can check all three of these off, the independent, the large sample size, and the random, that means that you can move on under the assumption that this you can use the chi-squared statistics. So when you do it, you add the column that calculates the chi-squared statistic to find the actual chi-squared statistic. So that's 4.2687. And then in a one-way table, you have to calculate like the degree of freedom. So the degree of freedoms is equal to the number of columns minus 1. So in this case, we had 6 colors or 6 colors or columns, and then we had to subtract 1. And when we subtracted 1, we got 5. So the degree of freedom in this problem is 5. Then that is used to find the p-value on the chi-squared table or on your calculator. Then we said the p-value that we found on the chart was greater than 0.25. That's extremely large, right? Large, large, large. And if it's large, what does that mean? Good. That means that in the conclude step, we can say that because the p-value is greater than our significance level, we can fail to reject, or we call it FTR, our null hypothesis. There is not enough evidence convincing us of the distribution of colors is different than the. Let's pretend enough was spelled correctly because this is hard to use.